Hello, hi guys. So today let's talk about this pointer and how this pointer works in C++. So for that one I created a simple example here. So here you can see this is a class test and it is having two interfaces. One is set value and another one is print value. Set value is setting the value to m underscore value, and m underscore value is a private variable here I have declared. So now let's see, like, by creating a instance, let's say t1, and let me create one more instance called t2. So as soon as we create like this, now what happens is, so this t1 is having its own copy of m underscore value. Similarly, t2 is also having its own copy m underscore value. But both of these instances shares the same function. So that means we do not have a separate copy of set value and print value for t1. Similarly, we do not have a copy of set value and print value for t2. But both of these objects shares the same functions. So set value is common for t1 and t2. Similarly, print value is common for t1 and t2. So if we want to call any of this function, we use t1, so the instance variable that is t1, and we can set the value, that is maybe 10. So but as I said, so the set value is common for both t1 and t2, whether you call with t1 or t2, so it will call the same function set value. But how come this set value will set the value to this m underscore value? So for that one, what happens internally is, so the compiler will change this signature into something like this: void set value and test pointer const this. This is the first argument which is passed to the set value, and the second argument is a int value, which is nothing but the same argument. And internally compiler, what it changes m underscore value to is, that is called this, and with this arrow operator, so then we are calling this m underscore value. So then this t1 dot set value is there, no? So this is getting changed to set value, then it passes address of t1, then as a second argument it passes 10. So this is what compiler internally does for us. So from this one it is confirmed that this set value is common. So here you can see we are not using any t1 dot or something, simply set value. You call set value as it is present outside this class, it is not belongs to this class. So simply call the set value and it passes the address of t1, and the second parameter is the parameter which is passed from the user. So now how can we prove this? How can we prove whether this is what it is happening? So to prove that one, let me print an address of t1. Let's say address of t1 is, so let's put t1 and \n. Similarly, we have passed the same thing, right? Let's put address of this pointer is, let me put this here. So now let me compile gcc, then a.out. So here you can see the address of this pointer is dd0, and this is also same address. So from this one it is confirmed that compiler is sending address of t1 as a first argument to this function, and also it is receiving with the name something called this, and this is what which is hidden from the end user. So it is hidden from the programmer. So every time whenever we do this arrow of this one, no, so this is the pointer which is coming from this parameter, first argument. So now let's see like what happens to this t2. Similarly, what we can do is we'll change this t1 to t2, then also we will call t1 dot set value of 20, something like this. So then again let me compile a.out. So here you can see 5a0, so this is t1 and this pointer is same, and second time when I call t1, so it's not t1. Let me change this one to t2. So let me recompile, execute. So here you can see t1 address and this pointer address is same, and t2 address and this pointer address is same. So from this one it is confirmed that So the address of this instance is going as a first argument to this function, and that is being captured in this pointer. So now we have seen this way. Now let's see like what happens if the instance is created with new operator. Let me do star p is equal to new test. So let me get rid of all this thing. So instead of t1, let me put p, and here also. So let me recompile again. So then a dot out. So here you can see. So where was something I did not. I have saved this one. So let me comment this part. So then I did not call this set value. Let me call that set value. Now let me recompile it again. A dot out. So here you can see the address of p is this something like eb0, and the address of pointer is also same. So that means in this case what happens is the compiler will change this set value to something like this. It is passing p, this is a pointer, and the second one is a value which is given from the user. So this is what it internally converts. So this is what this pointer works. So this is how this pointer works. Now the next question is like, why this const? So why this const is this pointer here. If we put a const here, so then the value is constant. If we put const here, you cannot assign this to something else, like you cannot do something new test or something like this. So the compiler will give an error. So let me compile. So here you can see L value requires as a left operand of an assignment operator. So basically, so you cannot do this one because this is a constant. Yeah, guys, so this is how this pointer works. So, and it is very much important concept, so which every C++ programmer should know. So I think this is what for the video. Then thank you.